this is page 6 of the IPC notes. Also happens to be section 6 on message queues, and specifically POSIX message queues. If you recall the taxonomy from page 1 of the IPC notes, this would fall under communication, data transfer, and message. Let's do a quick overview of what a message queue looks like. I'm not sure, maybe there's 10 or 11 there, something like that. And so the verbs that we use with the message queue are send. That's supposed to be an arrow. We're sending or putting into the queue, and we receive from the queue. And it also happens to be a priority queue. The priority is an unsigned int, 0 being the lowest priority. So when you retrieve messages from the queue, you get them in priority order. So let's just say that the first 3 messages in the queue have priority 3, and say the next 4 have priority 2, and then let's just say there is no messages of priority 1, the rest have priority equal to 0. Okay, so that's essentially it. So now let's look at the system calls. And the system calls are basically open, send, receive, close, and unlink. So we'll start with mqopen. Going to leave just a little room on the left there. So I said on the previous page that it used the open system call. It's got its own system call, but it is kind of analogous, or it uses some of the same concepts. So you give it a name of the queue that you're opening, and then you give it flags such as whether you're opening it read only, write only, etc. And if you are creating a queue with this call, then you need 2 more parameters. So I'll put them in square brackets here to show that they're optional depending on what you're doing. So the mode, which is basically the access permissions for user, group, and other, and then some attributes like the number of messages and the message sizes. So the return type is MQDT, that stands for message queue descriptor type. The name is going to be a const char pointer, so it's pointing to a C string. OFlag is of type int, mode is of type mode type, and the attribute is struct mq underscore attr. Okay, so the name starts with a /, but is not a file in the file system. It's got its own virtual file system. In Linux, that's mounted under /dev/mqs. I think it's plural. Anyway, I'll show you that when I go through the demo. The open flags are going to be one of, and these can be OR together, the logical OR operator, create. So if you're actually creating a queue, it doesn't exist yet. And if you're doing that, you can optionally specify whether it's exclusive. So what create does is if it exists, it's just going to open it. If it doesn't exist, it will create it. Exclusive says that if it already exists, you should fail. And then I just ran out of room on that line, so I'll do the rest here. So then these options, so O read only, open write only, so W there, and open read write. And of these three, you have to specify exactly one. I forgot to do that when I was working up my example that I'm going to show you. I was confused why it was not working. And that was why. If you don't specify any of those, you don't have read or write permission on the queue, which is kind of pointless. You can't do anything with it. Okay, the mode is going to be one of it's the access permissions like we have on files, and each of the mode macros, I guess, starts with an s_i, and then the last three characters are going to be either user, group, or other, and then the other character is the read, write, or execute. So this is the user read, write, execute permissions, and you can also, these can be written out in their octal equivalent. So if you press preface and numeric constant in C with a 0, then it's in octal, and so yeah, it's the same as for file permissions. So s_i read, now this is group, s_i, whoops, not read, write, group, s_i exec or execute group, and the octal for that, for these, it's like this. And finally other, which is OTH, s_i, read other, write other, and execute other. And the octal versions of these are that. Okay, so you can use these names, and you can logically order them together. So let's just say, for example, that we wanted user read write permission and group read permission. We could specify that as s_r user logically ordered with s_i write, user logically ordered with s_i read group. Or I could have specified that using an octal constant. So 0400 ordered with 0200 is 06. So that's the user permissions. And for other, we're just giving read permission. So that would be 4. And the other doesn't have any permissions. So one's shorter, I guess one's maybe more readable. Okay, and lastly, the struct MQ attribute, it has 4 fields, and those are MQ flags, and these get ignored when you call open, so there's no point to putting anything there. MQ max message is, how long the queue is, so that does not get ignored. You want to do that. And also the max message size, so MQ message size, And lastly, MQ cur messages, current messages, and that gets ignored. So it's this one you want to specify and this one. So how many entries are in the queue and how big they are. Okay, so open's the most complex one, and what it does is it returns a message queue descriptor or -1 on error. Okay, and the message queue descriptor has a lot in common with file descriptors. In fact, in Linux, it uses file descriptors for message queue descriptors, but that's not part of the POSIX standard. So I'm going to show you a very similar diagram to what we had when we talked about message queue descriptors, or sorry, file descriptor tables. So we've got the message queue descriptor table, and there's some information about the message queue, but nothing we're concerned about. But the important thing is that it has a pointer to a message queue so that's message queue descriptor pointer. And also used X and Y here instead of like 0, 1, 2, 3. It's not going to, if they're using file descriptors, 0, 1, and 2 are reserved, so it would be some number higher than that. But anyway, these are pointers into this table here, which has flags and then a message queue pointer. So these are the open message queue descriptors. So it's like the open file table that we saw before. And let me just label these. So each process will have message queue descriptor table. The open message queue descriptors is system-wide. And then we have the message queue table. So let's just say that this points over here. And so it's got properties and data stored for each table, or sorry, each queue. So let's just say that this one points here. Okay, and these are system-wide. So yeah, like I said, it's very similar to the way file descriptors are managed. Okay, and like with file descriptors, when we create a new process using fork, the child gets a copy of the parent's message queue descriptor table. So on fork, the child receives a copy of the parent's, I'm going to abbreviate this to MQ descriptor table, the one on the left. Okay, that's page 6. I got a few more system calls to show you, and I'll do that on the next page.